In this video, I'd like to talk about the math question of the day for Thursday, August 3rd, 2023. And with this problem, we need to find the solution of this exponential equation. And equations like this are typically seen in an Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you've attempted the problem, let's start working through it. And the general strategy for exponential equations is that we should solve for the exponential term and then either rewrite each side of the equation with a common base or use logarithms to solve this. Now, if we were to solve this for the exponential term, this 2 to the 3t over 5, we just need to get rid of this multiplication by 10. And we can do that by dividing each side of the equation by 10, so that we get 2 to the 3t over 5 is equal to 100. Now, if 2 and 100 shared a common base, then we can rewrite each of those with that common base and then just equate the exponents and solve for t that way. But because 100 is not some power of 2, and we can't write 2 as a smaller base, we can't use that strategy. But we can rewrite this as a logarithm. Since if we have, let's say, log base a of b is equal to c, then as an exponent, we can rewrite this in its equivalent form, where the base is the same. It would still have base a, since the logarithm has base a, and it's raised to the c power, since logarithms are exponents. So they are equal to the exponent, and then the input of the logarithm is what the exponential expression is equal to. And we are effectively starting here, and we want to go back to this logarithmic form. So then we can use a calculator. And rewriting this as a logarithm, remember that it has the same base as the exponential expression. We have log base 2, and logarithms are equal to exponents. So the exponent here is what the logarithm is equal to, and the input of the logarithm is what the exponential expression is equal to. We have log base 2 of 100 is equal to 3t over 5. And from here we can solve for t. We can multiply each side of the equation by 5 and divide by 3. And by doing so, the 3's cancel and the 5's cancel. So that we get 5 over 3 multiplied by log base 2 of 100, and this is equal to t. Now this right here is our exact answer, but if we do want to put this into a calculator, we might need to manipulate this a bit. Since some calculators will allow you to put in a custom base and a custom input, but many calculators, especially some of the older calculators or graphing calculators, might only have a logarithm button that looks like log or ln, where if it was, let's say, log of d, this is the common log, this is log base 10 of d, and if we have, let's say, natural log of k, this is a logarithm with base e. This is log base e of k. This is the natural logarithm. So e is the base of our natural logarithm, what we write is ln, and 10 is the base of what we call the common logarithm. So if you see log 100, this is log base 10 of 100, which we know is 2. So if you don't see the base, if it's omitted, you can just assume it's 10. Now, the reason I bring these up is that to use a calculator, you might have to use one of these logarithms rather than a special logarithm, or a logarithm of just any base. So let me make a little bit of room. And we just need to manipulate this answer. Let's just look at log base 2 of 100. And we can use what's known as the change of base formula. If we have, let's say, log base x of y over log base x of z, we can rewrite this as log base z of y. And in fact, we're starting with the right-hand side. If we have some logarithm and we want to rewrite it with some new base, where that base is x or whatever we want, then it becomes a ratio of two logarithms, where the base will now be whatever we want, And the input in the numerator was the original input, and our input to the logarithm in this denominator was the original base. So this log base 2 of 100, let's just use the common log. We'll change everything to log base 10. We'd have log base 10 of 100 divided by log base 10 of 2, which you'll just see for the calculator buttons as log 100 over log 2. And if we do want an approximation, we can again just plug this into our calculator as log 100 over log 2, so that t will be approximately 11.073, so we can just say 11.07. So this right here is what we think is our final answer. And to check it, we can just plug that in, 11.07. And when you simplify this left-hand side, since we are approximating t here, we will just get back an approximate answer. We can do 10 times 2 to this power, and if we get roughly 1,000, then we can feel confident that this is in fact correct.